Here's your script formatted for a smooth voiceover recording. Let's take a journey beyond our solar system to explore one of the most fascinating planetary systems ever discovered, Kepler-51. This star system, located about 2,600 light-years away in the constellation Cygnus, has puzzled astronomers since its discovery. Why? Because of its three unusual exoplanets, Kepler-51b, Kepler-51c, and Kepler-51d Spectra, which are some of the least dense planets ever found. Now you might be wondering, what does that mean? Well, these planets are about the same size as Jupiter, but they have incredibly low mass, making them puffier than any planet we've ever seen. Scientists have even nicknamed them cotton candy planets, because their density is so low that they would literally float in water if a giant ocean existed to hold them. But why are they so puffy? Astronomers believe these planets have thick, hydrogen-rich atmospheres that make them swell up like balloons. However, observations from the Hubble Space Telescope suggest that their atmospheres are filled with haze or dust, making it difficult to see what they are really made of. This haze could be blocking certain elements from being detected, adding to the mystery. What's even more interesting is that these planets might not stay puffy forever. Scientists believe that over millions of years, radiation from their host star could strip away their atmospheres, leaving behind much smaller, denser planets. In other words, we might be witnessing a unique stage of planetary evolution in real time. Kepler-51b, Kepler-51c, and Kepler-51d are often compared to cotton candy because they have densities of less than 0.1 grams per cubic centimeter, about 100 times lower than Earth's density, and even lower than Saturn, the least dense planet in our solar system. Scientists believe that these planets won't stay puffy forever. Strong stellar radiation from their host star may gradually strip away their atmospheres, causing them to shrink. In the future, they could resemble planets like Neptune or super-Earths. Unlike many exoplanets that orbit red dwarfs, Kepler-51's planets orbit a young, sun-like star. This raises interesting questions about why these planets are so different from the ones in our solar system. While all three planets are extremely low density, Kepler-51d is the puffiest, with a density comparable to a marshmallow. It has a size similar to Jupiter, but is only a fraction of its mass. The Kepler-51 system is estimated to be only 500 million years old, very young in cosmic terms. This suggests we could be witnessing a temporary stage in the life of planets before they lose their outer layers and become denser. Before Kepler-51's discovery, scientists didn't think planets could maintain such low densities at their sizes. Their existence forces researchers to rethink models of atmospheric retention, planet evolution, and stellar radiation effects. Kepler-51's planets are some of the puffiest and least dense worlds ever discovered, making them unlike anything in our solar system. Compared to Jupiter, which has a density of 1.333 grams per centimeter, and even Saturn, the least dense planet in our solar system, at 0.69 grams per centimeter, the planets of Kepler-51 are extremely lightweight, with Kepler-51d having a density as low as 0.03 grams per centimeter square, comparable to cotton candy or a marshmallow. These planets are similar in size to Jupiter, with Kepler-51d being about 10 times the size of Earth. But unlike Jupiter, which is 318 times more massive than Earth, the Kepler-51 planets have very low mass, making them incredibly puffy. Even per Neptune, which is about 3.9 times Earth's size and 17 times its mass, is far denser than these unusual exoplanets. When it comes to atmospheres, Kepler-51's planets have thick hydrogen-helium atmospheres, like gas giants, but they are filled with haze or dust, making their composition difficult to study. Unlike hot Jupiters, such as WASP-12b, which are dense and heated by their close orbits around their stars, Kepler-51's planets remain relatively cool despite their massive bloated atmospheres. They are also very different from super-Earths, like Kepler-22b, which tend to be rocky with thinner atmospheres. Scientists believe that over time, radiation from their star could strip away their atmospheres, eventually making them more like Neptune or smaller rocky planets. Kepler-51's unique planets challenge our understanding of planet formation, proving that the universe is full of strange and unexpected worlds. Earth has a radius of about 6,371 kilometers, while Kepler-51's planets are 7 to 10 times larger in radius. Despite their large sizes, these planets have extremely low masses, less than 5 times Earth's mass, whereas a gas giant like Jupiter is 318 times Earth's mass. This means that gravity on Kepler-51's planets would be much weaker compared to Earth's. Another key difference is their atmosphere. Earth's atmosphere is composed mainly of nitrogen, 78%, and oxygen, 21%, supporting life, while Kepler-51's planets have thick hydrogen and helium atmospheres that are likely filled with haze or dust, making them uninhabitable. Additionally, while Earth orbits the Sun in a stable, life-friendly zone, Kepler-51's planets orbit much closer to their star, meaning they may eventually lose their atmospheres due to radiation, becoming smaller, denser planets over time. The discovery of Kepler-51's cotton candy planets has given scientists a glimpse into an entirely new type of world, one that challenges everything we thought we knew about planetary formation. This script is structured to sound natural and engaging for a voiceover. You can adjust pacing, emphasize key points, and add dramatic pauses for effect. Let me know if you'd like any tweaks.